Okay, we're going to be talking about compound events and probability of what are called disjoint and overlapping events. So compound events are basically, um, the compound event is basically the intersection or union of two events. So it's like when you see these Venn diagrams where you see them overlapping, this section right here, this is that compound event. So again, these compound events are when things overlap. So like the union of A and B, the intersection of A and B, see how they're overlapping? That's a compound event. The overlapping event itself is when an event has one or more outcomes in common. Okay, so again, the overlapping event itself is actually what I should have said is the shaded in area. So that's those overlapping events that have event outcomes in common. Compound events are just two put together. They could intersect. You can also have an empty intersection. When you have an empty intersection, that's called a disjoint or mutually exclusive event. So it's when events have no outcomes in common. Okay, so the probability of compound events, we have two different types of compound events when they overlap, like these two overlapping, or when they're disjoint, like that last one over there, mutually exclusive. So if we have overlapping events, that probability is going to be, when you're looking at A or B, but they have outcomes in common, it's going to be the probability of A plus the probability of event B, but minus the probability of them both happening. So probability of A and B. Okay, but alternatively, if it's disjoint or mutually exclusive, then it's super simple. The probability of either A or B happening, because they have nothing in common, is just probability of A plus probability of B. Okay, so we're just going to do some examples to practice our probability of compound events. So if you take a look at example 1, two six-sided dice are rolled. What is the probability that the sum of the numbers rolled is a multiple of 3 or is the number 5? So you want to first ask yourself, is this overlapping or is it disjoint slash mutually exclusive? Well, when you roll a dice and you roll, or two dice, do they have, what are the possible outcomes, right? That's what you want to ask yourself. Multiples of 3, or is the number 5? So if you just think about that, can you have a multiple of 3 actually be 5? The answer to that would be no. So this is a disjoint event. If you're not sure how I got that, let's take a look at your sample space, okay? So I'm going to write out the possibilities of your two dice. So if you take a look at the sample space of your 36 possibilities, let's take a look at what are multiples of 3. So multiples of 3 are like 3, 6, 9, 12, 15, etc. So we're going to add the numbers because we're looking at the sum to see if we get 3, 6, 9, 12, etc. So 1 plus 2 is 3, 1 plus 5 is 6, 2 plus 1 is 3, right? 2 plus 4 is 6, 3 plus 3 is 6, 3 plus 6 is 9, 4 plus 2 is 6, 4 plus 5 is 9, and you see where I'm going with this direction, don't you? So 5 and 4, and then we get 9, and finally a 12. So those are the multiples of 3. Then if you want to take a look at what about just adding up to 5? Well, what are the possibilities? 1 plus 4, 2 plus 3, 3 plus 2, 4 plus 1. So notice how none of those yellow and blue, or excuse me, yellow and green highlighters mixed together. That's how you know for sure this is a disjoint or mutually exclusive event. So then I know I'm going to go ahead and use my second equation, the probability of being a multiple of 3 or the number 5 is the probability of being a multiple of 3 plus the probability of adding up to 5. So if you count the yellows, that's the multiple of 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 36 plus 1, 2, 3, 4 out of 36. And that's going to get me 16 over 36, which we're going to round down to 0.44. All right. So the key thing here is to figure out, is this going to be disjoint or overlapping, so you can use the correct equation. If you take a look at example 2, a bag contains cards numbers 1 through 20. One card is selected randomly. What is the probability that the number on the card is a multiple of 3 or a multiple of 4? So again, you can rack your brain and think, is there a multiple of 3 that's also a multiple of 4 that goes from 1 to 20? And you might come up with, oh, there's a 12, right? Because 3 times 4 is 12, 4 times 3 is 12. Again, if you didn't know it, write out your sample space. Okay, so I'm going to look for multiples of 3 in the card first. So that would be 3, 6, 9, 12, 15, 18. And then I can look for multiples of 4, which would be 4, 8, 12, 16, 20. So notice this big one right here, 12 got highlighted twice. That means there is an overlapping event, right? An overlapping outcome. So we're going to look at the equation for overlapping. So that means the probability of being a multiple of 3 or a multiple of 4 is the probability of being a multiple of 3, which are the yellows, plus the probability of the multiple of 4, minus the probability of it being a multiple of 3 and 4. And why is that? Because we want to take away the outcome that's counted twice. That's why we're taking it away. So if you count up all the yellows, including the 12, 1, 2, 3, 4, 5, 6 out of 20. Multiples of 4, all the greens, 1, 2, 3, 4, 5, so include that 12. So plus 5 out of 20. Then we want to take away that one overlapping event, so we don't want to count it twice. So how many times did they overlap? Once out of 20. So there's my probability, okay? So I get 11 out of 20 minus 1 out of 20, 10 out of 20, which is 1/2, or 0.5. Okay? So hopefully pretty straightforward once you've decided if it's overlapping or if it's disjoint. All right, next example. So if you take a look at example 3, out of 45 customers at Breakfast Cafe, 42 customers bought either coffee or orange juice. There are 30 who bought coffee or who bought orange juice and 40 who bought coffee. What's the probability that a randomly selected customer bought both coffee and orange juice? So let's start with what we know. We know that the probability of picking someone who bought either coffee or orange juice is 42 out of 45. We know that the probability of picking someone who bought just orange juice is 30 out of 45, and the probability of picking someone who bought coffee is 40 out of 45. I'm asking you to find what's the probability that someone bought both coffee and orange juice. Okay, so now if you go back to the disjoint probability equation here, we can, or sorry, overlapping probability equation up there, you see how we actually have all 4 elements? The or, the individual events, and the and. So we're going to manipulate this equation to find the probability of coffee and orange juice, right? So you know that the probability of buying coffee or orange juice should equal the probability of orange juice plus the probability of coffee minus the probability of both. Plug in what you know, right? 42 out of 45 equals 30 over 45 plus 40 over 45 minus the probability of coffee and OJ, all right? And just solve that equation. So simplify, 42 over 45 equals 70 over 45 minus the probability of coffee and orange juice. Subtracting 70 over 45. And that'll give us negative 28 over 45 equals negative probability of coffee and orange juice. So just some simple algebra here, right? Divide by negative 1, so our probability is 28 over 45. And we're going to round that to approximately 0.62. All right. Looks like this video is getting kind of long, so let's cut it off here. We'll do the last example together in class. So it should be a quick last example, and then lots of time to go over questions. All right, thank you for listening.